Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's presentation, Life Between Tides, Science and Survival in Antarctica, is brought to you by NatHab Expedition Leader Maru Marcias. A little bit about our presenter. Maru is a biologist from Buenos Aires who completed her master's research in Mexico studying whether whale encounters increase human environmental consciousness, leading her to specialize in science communication and marine conservation. She worked with the Whale Conservation Institute and transitioned from research to becoming a naturalist guide, leading snorkeling and diving adventures in Baja. In 2024, Maria joined NatHab as an expedition leader specializing in gray whale adventures, combining her biology background with science communication skills and extensive diving experience. Thank you so much for being here today, Maru. Take it away.
Thank you, Rook. Okay, let's just get started. Today's presentation is again very personal, as all my webinars have been so far. Try to talk a little bit about my bachelor thesis with macroalgae, but also the very special place where it took place, so Antarctica. Just to let you know a little bit more about that, you need to think that when I was a student, a bachelor student 10 years ago, when I did my bachelor thesis, I was living in Buenos Aires. I was far from the ocean. And so a dream for any person is to go to Antarctica. A dream for any marine biologist is also to go to Antarctica. But this was not necessarily my case. I mean, it was something that everyone talked about, especially in Argentina, because of our closeness to the white continent. But for me, it was all about whales. As Brooke mentioned, I've been working with whales since I was 15 years old. And so I wanted to do a thesis with whales. And the NGO that I was working with said, it's just going to take you too much time. We want you to have your title. We don't want to slow you down on your career. So don't do a thesis with whales. So I was like, oh my God, I need to find another subject that is not whales. So I was doing my subjects, I was doing everything, and I entered with a research person, and that didn't work out. So I was at the end of my career looking for something fast to do. Like I needed a subject that the data had already been taken. And that's a little bit what took me to being very lucky that they offered me this thesis of macroalgae, aka seaweeds, and they said, we already have collected everything. I will explain you how they do that. And you can just analyze the data and get the title. So as long as you know English and you can analyze communities, so this was something that I was very interested in also, you're good to go with us to start working in our team. So I started working with macroalgae group of the Antarctic Argentinian Institute, and this was in October. And I started just identifying algae at the laboratory, at the museum, and suddenly they said, you know what? There is a spot that just opened up. Normally, bachelor students don't go to the Antarctica, only senior students or PhD students or senior researchers. So they were like, do you want to go? And you can, of course, imagine that I had my luggage ready almost at that minute, right? So I was very lucky that I got to go to study my intertidal. I'm gonna explain just a little bit. And two disclaimers for this webinar is that this happened 10 years ago in 2014. So I'm gonna try to explain what I remember and what I started to come back with the memories. And so everything that I'm going to show you is from 10 years ago, so maybe some things changed to now. And also I'm going to explain a little bit about an Argentinian base, which is not necessarily how other bases, scientific bases in Antarctica work. Okay, so here are just two pictures of me currently and me at that moment studying macroalgae. So, okay, when I was coming back to this subject, when I was coming back to macroalgae, I realized, oh, maybe it's just easier to say seaweed. Seaweed is something much more known to you, probably as an audience. But what we need to know is that there are photosynthetic organisms in the world. The ones that we know normally are the terrestrial ones, which are the plants. And then on the ocean, you have two types. You have phytoplankton, which is microscopic algae, right, that they do photosynthesis. So it's microscopic means that you can't see it with your bare eyes. And it's the thing that you see on the right. So we're more used to hearing about phytoplankton, right? And phytoplankton actually produce more oxygen than the actual terrestrial plants. And they're everywhere in the water column. So the phytoplankton is just moving and drifting away with the currents. And that's why they're called plankton, okay? That's the meaning of that word, that is wandering, that is just going with the flow, right? Going with the currents. And on the left side, you see my subject of my bachelor thesis, which is the seaweeds, the macroalgae, which are these benthic organisms compared to planktonic. So benthic means that they are on the floor, on the sea floor, and they're also doing photosynthesis. So they are autotrophic, and they don't have a common origin. They have evolved from different groups. But what I can tell you is that they are a little bit simpler than the terrestrial plants in their structure, in their anatomical structure, and they are photosynthetic. This is what you need to know. And so they have a fundamental role in the coastal and intertidal communities. And these coastal and intertidal communities are not so widespread as the very bare ocean where we have phytoplankton. So they don't account for that much oxygen production, like only 1 or 2%. But in these particular places, they are the key species because they are the primary producers of this food web, right? So remember, we talked about in the last webinar about phytoplankton and krill being the base of the food web of Antarctica, but that is in the water column. And in the benthic community, these are the primary producers. The seaweeds are the ones that are going to feed, let's say, or hold the rest of the community that lives underwater, right? And of course, they are food source for all kinds of marine invertebrates like amphipods, gastropods, annelids, and so on. And also they can be shelter, right? Their tally, which is like, we would say the bark, but it's not the bark, it's a simple bark. Their tally and their roots, their primitive roots, let's say, can work as a shelter for other species to hide in, right? So in the next slide, we will see one particular species that you might know. And so the seaweeds have a growth and development that is going to depend on the light that can arrive to the place where they are, the temperature, and the nutrient conditions, okay? And so here we see the one that you probably know most, which is Macrocystis pyrifera. It's a type of brown algae that just generates the kelp forest. So these are the ones that, the only species that maybe generates, well, not the only species, but that generates these forests, these underwater forests that are so crazy. Here you can see a picture of me diving in one of those in Ushuaia. And here you can see a little bit what I was telling you, that there are 3 different groups that don't have the same ancestor. They come from different ancestors, right? So we have the chlorophytes, which are the green algae, and the rhodophytes, which are the red algae. They are closer together than the green algae. There is one group of green algae, the chlorophyte, that eventually developed in evolution and became the ancestor of the terrestrial plants, right? So we have these 3 groups. What do they have in common is that they are the primary producers, that they do photosynthetic, and that they are macroscopic, right? You can see them with your bare eyes, whereas phytoplankton are microscopic and are algae that you can't see with your eyes. So that's basically an introduction to seaweeds. And now an introduction to the intertidal zone. As I was explaining you in the introduction, I wanted to dive, I wanted to be in the ocean, right? But sometimes that is not possible when you're doing research for a bachelor thesis. So the intertidal was my connection, my door to the ocean. And it's also the door to the ocean in general. It's the place that connects the terrestrial part with the ocean part of our planet, right? So what is the intertidal? Is basically a place where you have the high tide zone, the middle and the low tide zone. So it's going to be moving around between being dry and being covered with water, right? So the organisms that live there have to be highly, highly adapted to those conditions. These are hard conditions because sometimes you're wet and sometimes you're dry. Sometimes the sun is just going straight to you and sometimes not. So desiccation, UV radiation, all of this, you have to be tough to be living in the intertidal, okay? And this place, this environment, you probably know about it. If you have been ever to a coastal area, you went with the low tide and you started just seeing what species are there. You probably started seeing the barnacles or some crabs moving around the tide pools. The tide pools are in the intertidal zone, and because they are a hole with water, some species are living there. You can see anemones, you can see all kinds of stuff, and this is a very interesting place for us as explorers, right? When we start seeing what is there in the underwater world, this is our first glimpse to that underwater world. And so because of their easy access and because of other characteristics that they have, these are one of the most studied environments in the world because they can help us to understand what the ecology of an environment is. What do we mean about this? Is that we have organisms that are mostly sessile, the barnacles, the limpets, the seaweeds. They have to be there hanging, right? Literally hanging in there in the rocks and waiting for the tide to come back. And so because we have sessile organisms, it's easy to study them. They are not moving around. They're not escaping from the scientists. So that helps a lot to research. Another important thing about these places is that they have a very wide variation or gradient of physical conditions in a very, very short distance. So we have strong variation, as I mentioned, of salinity, of temperature, of radiation. So this just helps them to be a natural laboratory. Instead of us going into a laboratory and just exposing different species to different UV radiations, here we have the natural place where that happens already, where there are variations and we can study how the different organisms react to those variables, right? However, even though intertidals are the most studied places in the world, Antarctic intertidals are not so well studied. And there is a few bunch of reasons because of that, as I found out when I was doing my bachelor. One of the things is that in Antarctica, you only have very few places that are ice-free during a period of time of the year. Of course, in winter, everything is covered by ice, but in spring and summer, some places, the red places that you see here on the picture, are going to be free of ice, right? Most of the places that are free of ice are in the Antarctic Peninsula and also in the oceanic islands that we have here around Antarctica. And so these places are probably the environment with the greatest disturbance in the world. So I already told you that these intertidal organisms have to survive to desiccation, to UV radiation, to all of these variations. So they have to be very, very resilient, right? But also in Antarctica, you have to survive to the fact that you're going to be covered by ice for several months. And also, it can happen that a glacier or an iceberg breaks down and the ice, the block of ice, just skirts around and just maybe removes the whole place. So if it's not sheltered, you may get wiped off by a big piece of ice. And also, the radiation and the temperature variation here is even more extreme than in the other intertidals of the world. So it's quite an interesting place to study the ecology of these organisms, right? And okay, so getting to a little bit about how can we do the research there, right? Remember that we talk about that Antarctica, it's a continent that is not owned by any country, but we actually have since 1959 the Antarctic Treaty, which just means that all the territorial claims are on pause, and this place is just a place for research and for peace. So if you have a claim there, the only way to acknowledge for that claim is that you have to do science there. Like if you want to have a presence there, that you need to do research there. And that's something that these 12 original countries are doing. And then there's this adding of more than 50 countries that have signed the Antarctic Treaty, and that are putting their efforts into being there, into being present, but they do this research for peace and for transmitting this science to the rest of the world. So it's a fantastic place in a lot of senses. We, in the past webinar, we talked about the tourism there, and today we're gonna get into a little bit of the science. So where did I did my bachelor thesis? So here is the South Shetland Islands, and we have Isla 25 de Mayo, or King George Island, which is this one that is just a little bit south from the 60 degrees parallel, which just starts the area of Antarctica, right? Here in gray, you can see the areas that are free of ice during the spring and the summer, okay? Remember I mentioned this, there's very little areas that have that. And in this red square is where we have the Argentinian Antarctic base called Carlini ex Giovanni. And just close to that, this is in Potter Cove. This is a small cove that you can see here. So it's a sheltered place where if you just walk maybe a little bit less than 2 miles, maybe 1 mile, you will get to the intertidal that I went and studied. Okay. How's the weather over here? Okay, we have a cold oceanic weather. The annual mean temperature is -2 degrees Celsius. That, if I remember correctly, something around 30 Fahrenheit. And then, if you remember last webinar, we were talking about the Antarctic circumpolar current that just goes from west to east around like this. So the most winds, the most frequent winds that we have there are northwest and west winds, okay? And this is just an amplification just to show you that in this island, we have a lot of bases of different countries. So we have the Brazilian, the Peruvian, Polish, Uruguay, Russian, Chinese, and Korean and Argentinian right here, right? So, of course, this is one of the islands in Antarctica that has the most scientific basis, and it's because even though we are in Antarctica, we are a little bit north, so everything is not that extreme, let's say. It is extreme because it's Antarctica, but it's not that extreme as being like, I don't know, in the South Pole, for example, or in the Ross Sea. So, so any country that wants to conduct research can build and have stations. So as you can see, there's a lot of countries in the same place and no problem because everyone is doing research, right? So let's talk a little bit about the research, but also I'm sure you're interested in how is life in a scientific Antarctic station. And as I already did the disclaimer, this was 10 years ago or even more, I think. And this is an Argentinian base. So I'm going to tell you about my experience there. And I, as I already said, but going a little bit to highlight this, that of course, I was very lucky that they offered me a spot there. I was also very lucky, but also you are at the right place at the right time. So if you're a biologist and you're in Argentina and you start studying something related to Antarctica, then your chances of going there are going to increase, right? And I think it's very interesting to show you that this is a map, a big continental map that they put in schools sometimes for us kids. So even though there is no territorial claim, for Argentinians, it's like we have territory in two continents and no less than Antarctic continent. So this is a very strong presence and very strong in our idiosyncrasy to think about. And also Argentina has the most number of bases. We have 13 bases. Most of them are here around the Antarctic Peninsula and the islands, and 13 bases between the permanent and the temporary ones. We also have the longest presence in Antarctica since 1904 with Orcadas base. So it's quite a deal here. Okay, so this is just a picture that I had on my article, on my thesis, showing a little bit more to set you up where we are. You're going to see that here's the Carlini base. Here you walk through the shore to get to the intertidal zone. And in this picture, you can actually only see the high level of the intertidal because you are in high tide right now here. So it's a little bit flooded, right? So we have to go to study it when we have the lowest, the most extreme lowest tide of the month. And you would see it a little bit like you see here. Sorry about the quality of the picture. They are from 10 years ago. So I didn't have a proper camera back then, but it's something like this where you can see the high, the middle, and the low level of the intertidal. And as I mentioned, the tides depend on the moon, and there is just one day of the month that you're going to have an extreme low tide, and that is going to allow you to do the research. Okay, I'll go into that a little bit later. What implications does that have to the daily life over there at the base? So let's see how I got there. Okay, I just thought about questions that you might have, and hopefully you have more questions at the end. So I'm going to try to go quick with everything so that we have time for questions at the end. How did we get there? Okay, this is the Hercules, the plane that the Argentinian Air Force has. So you can imagine that this was quite an experience because it's not a normal plane. These are the seats. So it's kind of like a military plane where you just sit looking at each other, right? You're in front and you see from the sides. So you're not looking at the front of the plane, you're looking to the sides, and you're just seeing everyone there as you fly, right? And the base where I went, that didn't have a place to land the plane at that moment. So we landed at the Frey base, which is a Chilean base. So once we landed there, we took this kind of Caterpillar transport to get to the shore, where we took a boat, and that boat took us to a ship. And the ship just went from Frey base, 40-minute boat ship transport to Carlini base, right? So a lot of means of transport to get there, you can imagine. And this is summer, so it's not that cold, let's say, but it's quite an adventure to get there. So this is a look from the boat of the base. This is the Tres Hermanos Hills. And here you can see a little bit of the whole place, but we're going to get a little bit on what do we have there on that base, right? Especially when you saw the Carlini sign, this is the fuel that we use for everything, for the energy, for heating, for the lights, for the scientific equipment. So we have this type of fuel tanks there. Facilities. Okay, so I stayed in this place that is called the New House. It's kind of like a hostel. The more young researchers stay here. And also just let me show you, of course, it has central heating. Here you can see whale bones on the front. And this was my room. And it's very simple, right? So you have what you need, the beds, a desk, of course, and the closet. I don't know if I have pictures of the closet. Here you can see a little bit, well, my mate, that is something very Argentinian. And here I was already, how do you say? I was already analyzing pictures from other years. I will get to that. So I was lucky. There wasn't any need for me to be there because there is a figure that is called the overwintering scientist that just collects the data that the research groups need when they're not there. So I was lucky enough to be able to see my intertidal, but the data that I use was not only from this year, was from many years before. It was actually a long-term study research, but I'll get to that in just a moment. Let's continue with the facilities. This is the dining house, so everyone eats at the same place. Here is the place also for meetings. And so it's a very nice place. It's just a less than 2-minute walk from the rooms to the dining house. But of course, if we have central heating, you have to just put on and off layers. I'm sure some people, some of the audience are from cold places and understand what I'm explaining, like get layers off and get layers on again to get out of the house and so on. So nothing too crazy about that. So in the spring and in the summer, we have more people, of course. The research mostly happens in the spring and summer months, so we can get up to 60 to 80 people there. But then during the winter, we have the military that stay almost 15 months, actually, throughout the year, and they continue to make everything of the logistics and stay at the base, just doing a lot of activities. This one is just to show that we separate the garbage and everything. Most of the things are going to get shifted back, so everything is separated, and most of the things are not incinerated by any chance. Most of it is just packed. Even the organics is going to get freezed and storage, and then packed and then sent back to Argentina, right? So only very few things are allowed to be burned inside, right? And of course the recyclables and everything like that just go back to Argentina, to South America continent. Here you can see the laboratories that we're going to see from inside a little bit. And here the tomatoes is the only private rooms that exist and are for special people like the chief scientist or the head of the base or the head military. So only a few people have their own private room, let's say, and quite small and cute room. Okay, more buildings. So this is a very big base. I actually feel like it has a lot of things. Like it's not that extreme. I mean, it has plenty of stuff. So here we have the Dalman rooms is rooms for senior scientists and for the collaborators of Germany. So we have a collaboration between these two countries that are doing research here. So they use our base and collaborate and study here as well. And we have the main house that I already showed you, the power plant, the IT room, and the meteorological station, and also satellite internet. I think back then we didn't have WhatsApp, or we had it very limited, and I personally didn't want to use it. But I think 10 years ago, I don't remember being on the phone in any moment so I was there for a month, and I remember I had to use the satellite phone to call my dad on Christmas, but we'll get to that. So yeah, we also have a chapel in case there are people that are in need of using this facility. The nursery here, and the carpentry, and here is the new house again, where the young students stay. Okay, laboratories. Here I was, let's get a little bit with the research. Here I was rearranging my sample quadrant, just because I wanted to look very perfectly aligned and all that. So here you see me Sorry. So also, if you need to do something very specific that requires more technical knowledge, or you have to use a saw or something like that, there is a particular technician that can help you out with anything that you need to rearrange. So we have a technical person that knows about everything and can help you with anything that you come to your mind and need to rebuild or redo. Here you see me at the intertidal, just putting the quadrant for taking the pictures of the algae, because we are in a protected area, especially protected area, so we did not collect the algae. Most of the studies that are done with algae in general, maybe you collect them and you take them to laboratory to measure stuff or to put them to different nutrient conditions. But remember what I explained, that this is a natural laboratory. So if you can study systematically what happens throughout the months or throughout the years, just by taking pictures, you can study the structure of this community, of this intertidal community. Like, which species do you have? How much coverage do each species have? When are they there? Are they all the months there, or are they there only in the summer or only in the spring? So all of that you can get from just taking pictures, right? So this is a picture of the sample. Basically just to show you what it looks like. Remember I said that we have to go on the very low tide. If that day, for any reason, you have a wind, the wind is just going to blow the water in and it's just going to ruin the picture. So sometimes you don't have good conditions to go. So it has to be the perfect moment, the perfect timing, and everything like that. Lucky for me, and that I had this overwintering scientist that he took pictures on 4 different years, 4 different summers in a variety of days, between 20 days of difference. So you can basically say, okay, 4 different summers of 4 different years. That helps you to study the spatial composition of the community. Because you're taking the same picture in different years, but at the same time, right? And also, if you want to study the variation of the community in time, what we did is study 5 different months of the same year to study the temporal variation between the species composition in spring and summer, right? So what happens, which algae start growing in spring and which ones wait until it's summer and the conditions are better. So this is just to show you an example that, okay, what I do is I just see which species do I have here. Remember, I was in the museum, in the laboratory, just learning the different species. So I just see which species I have and how much do they cover here, right? So that will give me the species composition and the abundance of each, right? And so this I did, remember I told you I was analyzing in the computer. So I take the pictures and then takes me months to analyze the pictures that I took in this particular day in Antarctica, right? Months after, I would be analyzing this because I had 383 pictures like this of the different places, of the different zonations, of 4 different summers, of 5 months of the year. And not gonna go very deep into that. There is an article that you can read, but what I can basically transmit from this amazing work that I was able to participate in is that we have 15 different species there. It's a very established macroalgae community or seaweed community with 2 green and 5 brown algae and 8 different red algae that are going to just vary throughout the year. For example, another just curious data that I can tell you is that this species, the Pyropia, is the one that you, not this particular species, but this genus, let's say, this equivalent of this one in other places is used for the sushi wrap, right? So we have an Antarctic version of that sushi wrap. Of course, I didn't try it, but I'm sure it tastes just the same as the other places, right? So one important thing about this being a very established community of seaweeds is that it can help us understand what happens throughout time. For example, with climate change, are the species going to survive to the different changes in temperature? And so, yeah, definitely these are very hard, tough algae that survive in this particular place. Um, and so just a little bit about the differences. In the medium level, we have different species and different types of substrates that allow them to colonize there. And the low level is more closely similar to the subtidal. So there's going to be a little bit more competition in that area because it's more stable. They have more water during time. So only a few species are the ones that are going to dominate. Whereas in the medium level, we have the hypothesis of medium disturbance. So it's kind of like it's not that tough as the high level, but it's not as stable as the low level. So this allows you the maximum diversity, the maximum amount of species, okay? And then, of course, in the high level, you have these tough, very, very tough species, only a few species that survive, very low coverage, very low number of species, because it's the place that gets most desiccated during the low tide. This is the same rock that I'm showing in that diagram. You can see maybe a little bit of this species that I was talking you about, and and here I'm just collecting other data like salinity, temperature, and so on. One thing that I want to point out, it started to snow, very mild snow, but you can see it's cloudy. You can see that it started snowing. So we needed to do this very fast before the tide comes out and before the weather changes. And just a big applause to my supervisor there, my co-supervisor there. She taught me everything that I needed to know to become a good scientist. And so I love this picture that I didn't know was taking. They were taking it. The overwintering scientist was taking this picture, and she's just showing me, and we're just discussing stuff. And one thing I totally didn't expect it from her, that she was very serious. But my first day of field work ended up with a snowball play. So once we finished, she just started throwing snowballs at me, and I think it was one of the best moments of this month that I spent in Antarctica, because I totally was not expecting that I would end up in the floor because of this snowball fight. Okay, another thing that was very interesting about this month in Antarctica is that, remember that I said that I was only there for a month, but I could only go to my intertidal during one day. So what did I do? What did I do the other 29 days that I was there? So people were like, okay, do you want to help us with other research? And I was like, wow. So this is for a biologist, it's amazing because you're learning from different research groups and you're helping them. And in this case, I was doing very interesting duty that maybe you're not familiar with, that scientists are going to have to do this, but this was for a study where they were actually doing an experiment underwater of the ice scoring. So they painted these yellow blocks of cement, and the ice is going to remove it whenever it passes by. So they were studying the colonization rate, or the different ways that the ice core is affecting the subtidal communities. So very, very interesting, but someone has to put these blocks. Who puts these blocks underwater? Okay, so you have the military divers that help with this particular type of research. So very, very extreme, and we'll get to that. Unfortunately, in that moment, I was a diver and I was a scientist almost. And I didn't have my title yet, but I was a biology student. But according to the law of Argentina, I was not a scientific diver. You need to get a special course for that. So I wasn't able to dive there, which made me very, very sad. But at least they let me be on the boat, collecting data, helping them to collect the data. And here you can see one of the equipment that they have is this immersion suit that is, if you fall down, is totally waterproof and thermally good. And this is the smallest size that they have and still looks kind of very bulky, which I think is funny too. And so my group, the macroalgae group, was doing several different research, not only the intertidal, but the subtidal as well. Here we were doing some other research with collecting plankton. And here, if we have a little bit, maybe just 30 seconds or something, so you can tell me when I was there doing the research in the boat, can you guess what time it was? Can you help me with that, Brooke? If someone can put on the chat.
No guesses yet, but
Okay.
can I guess?
Yes, you can get for
Okay,
sure.
we're getting several midnight guesses.
Okay.
Noon. So the
Nice.
exact opposite, a midnight and a noon.
Okay.
Eclipse? That's another one.
Nice.
Um, yeah, another
Yeah.
noon. So it seems that we have exact opposite times.
Okay,
Nighttime.
okay, got it. What was your guess, Brooke?
My guess is like 11 p.m.
Nice. Actually, you're right on it. It's
Oh,
11
nice.
p.m. Yes. So in summer, we have 20 hours of daylight, and then we have 4 hours of twilight, actually. So it doesn't really get dark in the summer. In this particular part, we are still very north, so you still have these changes of the day, but I think it's quite extreme that you can go and do your field work day at 11 p.m. because the conditions were good, so we decided to go out and do the research. So it's fine. Very nice, very good guesses, people. And okay, another thing that was amazing, I honestly didn't help that much. I was just there going with them as a company because the experts for the marine mammal census were others. So they allowed me to go with them and to do the marine mammal census that they do every so on frequently, where they are seeing the sex, the class, age of the southern elephant seals and whichever other marine mammal you can find out. And also something interesting is that some of the researchers, the one that were studying penguins, would stay in refuges. It's a difference between bases and refuges. So they would collect all the food that they could collect and stuff for the days that they needed, and they would stay in this refugee for maybe 3 or 4 days and then come back to the base. So this was a walk that was 7 kilometers, so I think it's 3 miles. And so they were 3 miles from the base, so they would not come back every day. And these people were even tougher, right? The weather can change a lot. Here's the three hills on a sunny day. Here you can see the volcanic origin of the island, which is just beautiful. And also you can see that this is one of the places that gets ice-free during the summer and spring. And so you can see this dark land, right? But also some days you're going to have a little bit of rain. Most of the time snow, but sometimes there is a little rain or the light rain. I don't remember how to say in English, light rain. And then snow, right? Snow up until this is the window of my room one day after a storm, a snowstorm. And so I woke up and my window was 3 foot of snow, or even more than 3 foot, I think. And sometimes for sleeping, I had to close the curtains because of the twilight. So when I open up and this was like, oh well, okay, we had a little snow yesterday. Weather. Well, this one is in Spanish. I'm sorry about that, but this is something that got my attention because here it shows you how the wind, just the wind field, decreases the temperature so much that you need to be very careful because sometimes if you have the parts of your body exposed even for 30 seconds, it can get frozen in this weather. So here is just a chart that shows you the actual temperature and the wind field. so that you know that when there's wind, you need to be very, very prepared, right? So we had a few wind storms, but very, very few. And of course, we didn't go out, or we went out properly dressed when we had that. And my favorite place is where the divers were, of course. This is the dive and navigation station. It has tanks, it has a compressor, it has even a hyperbaric chamber in case there is any emergency and you cannot go back to the other continent to get help. You need to solve it right there. So of course there are people, there are staff there are doctors. There's always one doctor in the staff. There's always one the technician that I mentioned. There is an IT technician as well in case you have you need something. My computer actually got broke, the cooler, and so we couldn't fix it, but we found out that the solution was putting my computer outside for a second so it would get cold, and then I could get it back inside and work on my thesis. But yes, there is a technician there for electronic stuff, so for whatever problem you may have with internet or whatever. And so here are some phrases. They are in Spanish, but it just shows you my admiration for them and how tough they are. Remember that I mentioned that they are diving in very almost less than the freezing point of water is the water temperature. So the hardest thing always, we hear the song of the sirens, but we're not seduced by them. Here, the easy it's done, the difficult is being done, and the impossible takes a little while, but it gets done, So these are the phrases that were around that place and just so inspiring with these tough men that were doing the diving research. And so these are the boats on a glassy day. It's looks very calm, but it can change in very short time. Also, everyone helps to do everything. As I already mentioned, I have the possibility of helping everyone. Here you can see some that have the immersion suits and some that have the dry suits for diving, right? And so, of course, you probably wonder about the social life. I was only there for a month, so I don't think I got very, very isolated, but this is the inside of the diving station in a birthday time that we had. And we prepared a cake for the divers. And so to celebrate, and of course, they were very happy because actually this base is the one that has the most number of scientific women. So other bases have a very different rate of men to women. So it's kind of like even though it's extreme, I think it's the less extreme of the bases that I know of. It's the only one that I've been, but that's what they told me. So we did have a chef, but sometimes if the chef is off duty, we would switch and help. This time I had to cook for 70 people. I cooked pasta. And one thing that was funny also is that one time we did a gambling game and my prize was an orange. This may be strange, but guess that only one time a year you get all the food, and the food would be stored in warehouses or in a freezing chamber, right? But the things that are going to perish sooner are, of course, the fruits and vegetables. So these were very unique prices, and I think it just shows you how we take for granted some small stuff, some simple stuff of everyday life. For me, it was a funny anecdote, but think about the people that live there for 15 months, okay? How priceless it was to get certain food items when the summer people arrive and bring all these things from Argentina, right? So just that. This is my window. Sometimes you have a natural freezer outside of your window to store food, to store some beverages, why not? Another funny picture to show. And very important for isolation is the games and play. So we had a multiple use house. It's actually very well equipped. It has a ping pong table. It has a movie that on Fridays we would do pizza and movies. And on Saturday it becomes a dance floor. So I think it's very, very, very well equipped, this base. And as I was mentioning before, the only time that I used a satellite phone was to call my father to tell him Merry Christmas. Spending Christmas and New Year in Antarctica is just an amazing experience. Here you see Santa Claus dressed as a diver, so I was in my very prime moment with everything related to marine biology, to diving, to science. So it was very nice. We had very good food for that special occasion, which is not always. Normally is pasta for the cold, but here we had a very good supply for special occasions. And here you can see a little bit of all the people that were in the base. So you can see that a lot of people that then become your friends and family in those times of isolation. You can see that they're very happy. So a little bit to close up, what can we say about this? I'm very, very thankful for all I learned. I think it was a very good start. I think it just put the so high the bar for science, but it was a very, very nice experience to do science in an extreme place where I think if the seaweeds show you how resilient they are, how they survive to these tough conditions. For me, it was just a month, so again, it was nothing compared to what these people survived there. But definitely, it just shows you how the best and the worst may come out in when you're in hard conditions. But I think in this case, in the case of Antarctica, we it gets the best of us, the collaboration. So it's a place for science, for collaboration, for cooperation, and also for respecting our world. And so I would like to invite you to see my previous webinars where I talked a little bit more about these adaptations that there are for climate change for this for the seaweeds and other species, and about the tourism that goes on there in Antarctica. So this was supposed to be a series of webinars. So these three are my series of webinars about Antarctica. And I hope that you have a lot of questions. I also want to close by saying this, that we have an intertidal here that is surviving climate change. And so, as I mentioned, that the seaweeds and this community is a natural laboratory, an ecological model that helps us to sense any changes that can happen, because these species were there in different years, and we still have the same species over time. So it's a very established community that if something happens, they are going to be the first ones to let us know. And that's why this community help us to understand what the changes that are happening in our environment, and especially in a very fragile but resilient place like Antarctica. So thank you for your attention, and I hope you have some questions for me.
Maru, that was amazing. Thank you for taking us on that virtual trip to your research life in Antarctica. I don't know if anybody listening has had a chance to do that, but I know I definitely have not. So thank you for just opening that window a little bit for those of us who are very curious on what it's like to do research in Antarctica. All right, everybody, we have a few minutes left with Maru, so go ahead and put your questions in the GoToWebinar control panel, and we'll get through some of them until the top of the hour. Okay, great here. Could you explain a little bit more about the grid system? How exactly does that work? Did the grid move when you were doing your research, or how did that function?
The grid, you mean the quadrant sample, right?
Yes. Mm-hmm.
Okay, so basically we do transects in the three different levels of the intertidal, in the low, middle, and high level. And we do the transects that the first quadrant is thrown randomly, and from there you have a particular systematic distance between the transects. And so you take pictures, let's say 10 quadrants in each transect, and then let's say 3 or 4 transects in the middle zone, 3 or 4 transects in the low zone, and only 1 in the high zone because it was a very short place. And so then you take you choose random quadrants and pictures, and then you analyze the number of species that you have and the coverage of each species there. So then you can compare which species do you have in each level and how abundant they are in there. So it's a very basic ecological study of the structure of the community, but totally I can send you the article if you want to see more about that methodology. But the important about that methodology is that you are not taking out the algae. You're just taking a picture of the species that you have there. And so that is very good for conserving this place, because you can understand how it changes through time, in the years and in the seasons, without taking out any samples, right? So I don't know if I answered the question.
Yeah, no, that
Mhm,
was great. Thanks. Yeah. That was a great overview of the methodology of the actual research
mhm,
you did. So thanks for that.
mhm.
Next, what are the predators of the seaweed? Who are the creatures that are eating it, if there are any?
Yeah, that's interesting. Well, only not that many actually in this particular area, but definitely the limpets. The limpets are the ones, the invertebrates that we see more often here. And in the subtidals, you would have even more predators than in the intertidal. Of course, here we don't have, as in other places, that much fauna, let's say, that is going to eat them. So they kind of like thrive a little bit here. But yeah, yeah, yeah.
Oh, fantastic. Well, we are down to the last minute 30 here, so we are really close to the end. So, Maru, I would love to turn it to you for any last closing comments.
Oh, okay. So just here you have my email if you have more questions, if you can think about them, and the dates that we have trips. And also I just would like for you to think about this amazing place, and just think about it's an example for the rest of the world of how research should be done, collaborative, and that we share everything that we learn there with other researchers and with the rest of the world. It's a place for peace, for science, for research, for tourism also, and I think it's a good example of how we should treat other places in the world with just the same fascination, the same uniqueness, because every place that we visit deserves our respect and our admiration, just as Antarctica. So thank you for listening.
That was a great way to close it out. Could not agree more, Maru. Thank you so much for taking the time to give us this amazing presentation today. And I would like to thank everybody who tuned in. If you're interested in information on how you can travel with NatHab, give us a call at 800-543-8917 or send us an email at info@nathab.com. Our adventure specialists are more than happy to help you. Join us Monday for our next daily dose of nature. You can check out next week's lineup, including registration links on our website at adhat.com/webinars. We did record today's presentation, and the replay will be available on our website soon. With that, I will conclude the webinar. Goodbye, everybody.